The first step of implementing a controller is to design the sensors and actuators and how those are going to fit together into a control loop. In this case, we're going to design a controller for the temperature control lab. Now, the temperature control lab has an Arduino, and we're connecting to analog pin 0 for temperature 1 and analog pin 2 for temperature 2, and then digital pin 3 for our heater 1 and digital pin 5 for heater 2. We want to just do temperature 1 and heater 1, and we're going to design our control system and then also show it in a block diagram. So let's go ahead and just get started by reading the objective. We want to design a controller for the TCLab with a process diagram and feedback control block diagram. If you'd like to follow along with this, there's a link right here. I'll also put that in the description, and it'll show you the assignment and then also some of the solutions down below. Okay, we have this diagram of our sensors and actuators. Let me just go ahead and indicate here on the right where those are actually located. So you have a heater that's right here. It's a transistor heater, and this is for temperature 1 right here. So we're just going to be doing the one on the right hand side, and then right below it, that is our temperature sensor. Okay, there's 3 prongs for that one that hold up. It's a very small thermistor that's attached to the transistor heater. Okay, so those are our actuator, which is the heater, and the temperature sensor, which measures our current temperature in degrees Celsius. Okay, here's the overall diagram. What we're going to do is indicate what is our temperature transmitter. In this case, this signal right here is our temperature transmitter. And then our temperature controller is going to be here as well. Just do a dotted line for that to the temperature controller, and then that is the output of that is then going to go to heater 1. Okay, so here's our diagram that shows the transmitter and the controller. Now, if you have other things, you can also indicate those. The first letter is the thing that is the thing that we're trying to measure or control. So if we come to the controller design, and then here on the right, introduction, it'll show you a list of those symbols that you can use. These are typical diagrams that show the transmitters and controllers, and here you can see the letters. In our case, we have the measurement is a temperature, so it's going to be T. And then we commonly have, for example, controllers or transmitters or transducers. Okay, so those are the letters. The second letter is the type of equipment that it is. And the first letter is the quantity, like the measurement or the type of controller. It's the quantity that we're going to be controlling or transmitting. Okay, so if I come back to this diagram, that's why I have the 2 letters there. The first one stands for temperature, and the second one is transmitter. And often what they'll do is do a circle and then maybe a TT, and then you could have something like 102. So it's temperature transmitter 102 if you have a lot of them on the diagram, and this would be a temperature controller, typically same number. Okay, so there's our diagram. The dotted line, that often means like a signal. Just to differentiate, if you have flow loops or things like that, you can see a dotted line to indicate that it's a number or a signal that's being transmitted. Okay, so let's go on to the second one, the second part of this question. After we've done the temperature transmitter and controller, we want to do a block diagram now. And as opposed to a process flow diagram or a P&ID, a process and instrumentation diagram, we are going to be doing a block diagram, and this shows the flow of information, especially for control loops. And so what we're going to do in this case is just indicate not only for the blocks but also for the signals between them. What are the signals and what are the individual blocks here that make up this block diagram? So first of all, we have here on the left, we have our set point, and that is a set point for temperature 1. That's our desired target value. And then we also have a process variable, and that is the measured temperature 1. It's going to be coming from the sensor. In that case, it's the three-pronged little thermistor. Okay, and we're going to be reading that. The thing that it reads is it takes the actual temperature, and so this is going to be in degrees C, and it's going to convert it into a millivolt signal, which then will transmit into a temperature. So this one's in millivolts, this one's in degrees C, and the sensor transmits something from the physical units into something that's a signal that can be then processed, maybe converted into a number. Okay, we're going to compare these two. This little addition thing, it has a plus sign and a minus sign, meaning that the error is just going to be the set point minus the PV value. Okay, so that just simply indicates that we're subtracting one from the other, and then that becomes our error between the two. It's going to come into a controller, such as a P&ID controller, and then we're going to produce an output, a recommended output for the actuator. In this case, the actuator is the heater. It also has the 3 prongs. It's a little bit bigger, but it has the finned heatsink that it's attached to, and that is our actuator. And then our process is the actual TCLab with the heaters and temperature sensors, and so we put in a different actuator value, and then out comes after some delay here. We have a little bit of a delay, and then this is going to be the temperature that the heater had caused. Okay, so that's the temperature 1 that the heater actuator had produced. Then there might be disturbances as well. Some of those disturbances might be from things like ambient temperature. It might be from temperature 2 if we turn on the heater 2. And so that is going to be also the Arduino device for our the ambient temperature, or temperature 2 is going to affect the other temperature sensor here, and then that is going to be the temperature 1 addition from the disturbance. Okay, and then we're going to add those two together, those two changes together, and then that's going to give us our actual PV, or that's our temperature 1. That's our measured, not measured value, but our actual in degrees Celsius. Okay, and that's going to then convert it into a millivolt signal, and then we go around that loop again. Okay, so here is our diagram where we've put in the sensor, the actuator, and the process, and then identified some of the potential disturbances. Okay, so just to compare with the solutions that I put there, you can see the one thing you might want to do is just add in the disturbance, like an ambient temperature that might be measured or unmeasured. Temperature 2, that one is likely going to be a measured, and ambient is not going to be directly measured, so it's going to be an unmeasured disturbance. Okay, so that is our controller design. Again, very first step of implementing a controller is just to identify what is going to be the sensor, the actuator, and the controller, and then you put those together in a process and instrumentation diagram, or you can do it in a block diagram form, okay, like we did below. So both of those are very helpful in seeing the flow of information or where the instruments are attached to the process. Okay, for our next up on this, I'll give you a quick overview of where we're going with the controller design. We did the modeling previous to this. That was 1 through 6, and then we have 7 on down. This is our process and block diagram. We have P-only control is up next, PI control, and then PID, and then we're going to do some tuning, add a feed forward, take a look at the actuator and the sensor. So that all goes into designing a controller and some of the theory and applications behind developing a PID controller and tuning it.